As we look out into the universe, it looks like there are an incredible number of places that life could exist. The materials you need to make life are everywhere, but the big question remains, is life out there?
For over 50 years, we've been searching for signals from advanced civilizations and sending powerful intentional signals to nearby stars in the hope of getting a response back.
Talking to extraterrestrials would be meeting another civilization, and so that encompasses everything, not just science.
It's a very difficult problem to compose a message when you don't know what the people on the other side are like.
One of the things that make it extremely difficult is the fact we don't know what we're communicating with.
Is ET a machine? Is it some sort of hybrid with a machine inside a human brain? Or is it a human plus a computer?
I'm not 100% sure whether we should actually go ahead and send a message. If was a belligerent society and they did have the capacity to do damage to our society, then it would have been a terrible thing to send such a message like that.
If we can discover what an advanced intelligent civilization is like, we'll find out what we're going to be.
The decision to contact them or not is very controversial, and its consequences are unpredictable.
It's a very different future for humans, I think, if we're the only ones in the universe versus if we're going to be interacting with extraterrestrials out there.
In 1971, in the middle of the Cold War, the Burakin Observatory in Armenia witnessed an unprecedented encounter. 50 scientists from the Soviet Union, the United States of America, and Europe met for 5 days to debate what communication with extraterrestrial intelligence should be like. Among those scientists were renowned names, such as Nobel Prize winners Francis Crick and Vitaly Ginzburg, physicist Freeman Dyson, and astronomers Nikolai Kardashev, Carl Sagan, and Frank Drake. A year later, Sagan and Drake were in charge of designing boards installed on Pioneer probes 10 and 11 from NASA, considered to be the first physical messages destined to explain Earth and humanity to a hypothetical extraterrestrial civilization. As of today, we are still sending messages to the stars, messages that, so far, have not been answered.
In our galaxy alone, there are billions of stars and billions of galaxies in the universe. And we now know that virtually all of those stars have planets around them. So there are a lot of places that life could exist. And as we learn more about the universe, we realize that the basic building blocks of life are everywhere.
The building blocks of life, carbon, oxygen, hydrogen, nitrogen, sulfur, we know are present certainly in our own solar system. So that's not by accident. It turns out that oxygen, for instance, is the third most abundant element in the universe after hydrogen and helium. We think that water, therefore, is also very abundant. The basic things, atoms and molecules of which we are made and that life depends on, are ubiquitous. They're all over the place. And so that's a reason to be optimistic about finding life on other planets.
Astrobiology has grown over the last few decades. The idea of astrobiology is to look for life on other worlds in outer space.
Astrobiology is divided into 4 different areas of research: planetary science, planetary systems science, the origins of life, and finally, SETI, or the search for extraterrestrial intelligence, and METI, or messaging to extraterrestrial intelligence.
For over 50 years, astronomers involved in SETI, the search for extraterrestrial intelligence, have been using telescopes to look for the telltale signs of advanced technologies. A signal that stands out from the cosmic static as distinctly artificial.
So far, we have not received any signals that we would identify as being of both extraterrestrial and artificial or technological origin. We don't have any examples that we can learn from yet.
I think one of the difficulties with SETI in general is that it is potentially an extremely long-term project on the order of hundreds of years. And that's not something humans typically engage in. We don't usually do projects that last that long. We've only been looking for about 40 years, so if you think about the distances that are involved, 40 light years from here is a tiny distance, so, you know, if something was within 40, let's say 30 light years that had sent something to us, well, we might have gotten it. But we don't look all the time, so we'd have to be looking for it at the moment it showed up. So it's possible things have, you know, gone past that we didn't intercept.
Despite almost 50 years of searching, we have not yet found any kind of evidence of the possibility of extraterrestrial intelligence. However, the discovery of the existence of thousands of exoplanets has been a game changer in the search for other intelligence. We can now know which stars have planets around them, and which of those planets are Earth-like. That means we know now where we can point our telescopes to look for a twin of Earth.
An exoplanet is just a planet around another star. And of course, the astronomers had thought for many decades or even longer that there probably were planets around other stars, but we didn't really know that for sure until 1996 when the first exoplanets were discovered. By now, there have been thousands of exoplanets discovered, most of them by Kepler.
Big question is whether those planets have life on. We know here on Earth that it's ended in life and mind and intelligence. So the question is that common? We know now that planets are common, but is life and mind and intelligence common on those planets?
There are 2 fundamental requirements for a planet to become potentially habitable, and a third one, which is debatable.
So the first absolute requirement is that a planet have a liquid or a solid surface. It can't be a gas giant. And that's because life needs a stable pressure temperature environment in order to get started and to maintain itself. So we're interested in what we call rocky or terrestrial planets. Second requirement, I would say, is that you have to have carbon available at the planet's surface because life on Earth is carbon-based. And then the third requirement, which is more controversial, is liquid water. So all life on Earth requires liquid water during at least part of its life cycle. So I think that if we do find life out there, it will also depend on water. The discovery of exoplanets has, I think, advanced both SETI and METI enormously. Now we know there are exoplanets. That means the chances that SETI could succeed have gone up.
Since we know there are planets like the Earth within a few tens of light years of Earth, if we send a message out to these planets and they reply at once, we might get an answer back in 20 or 50 years, and that's the sort of project we can do now.
We know that this project has to cope with many difficulties, like the vast distances in the universe, or the uncertainty of the existence of another intelligent civilization anywhere out there. We are just at the beginning of this amazing adventure.
With METI, we're taking the next step. And not just listening, but sending powerful, intentional signals to nearby stars in the hope of getting a response back. So in SETI, we are searching for life beyond Earth. In METI, we are actively sending messages of our own to make contact.
Active SETI or METI is an attempt to actually, I don't know if I could really say initiate contact, but if there is anybody else out there, to potentially let them know that there's somebody here that is interested in communicating.
So in general, I believe that the process of going through the design of a METI program would teach us a lot that would be directly relevant to SETI. The reason being that the problem is really two-sided. Every encounter between civilizations has to involve both a message sender and a message receiver. And by looking at the message sending aspect, we'll learn a lot about what we should be looking for on the receive side.
The creation of a message that could be understood by an extraterrestrial intelligence is a huge challenge due to the lack of a common language. If we wanted to engage in a dialogue with extraterrestrial beings, we should have to consider another added difficulty: the huge distances separating us. A single signal could take many years to reach its destination, and a possible answer could also take years in coming back.
As we create a message to another civilization, we need to find a common language. Well, we know they're not going to speak English or Chinese or Swahili, so what language then do we use? We find some of the most basic principles that you would need to know in order to be able to communicate at all. As we are trying to create a cosmic language, we have to ask ourselves, what do we and the aliens have in common? And one thing we will know if we get a signal is they can create the signals. So what does it take to create a signal? Well, you probably need to know at least some basic mathematics. You need to know some basic physics. And so that is the foundation for the messages that we create.
The communication process is not easy at all. Here on Earth, if we think about our own species, the communication between two human beings of different cultures and with a different language is really difficult, because despite being very similar, we are also very different in many respects.
An example that I like to use of this is, you would think counting would be something that would just automatically translate easily across different languages, but it doesn't. When counting, English speakers and Japanese speakers actually encode different information into the process of counting. For English speakers, it's important to differentiate between one and many, thus we pluralize things. In Japanese, they don't pluralize things. Instead, they differentiate on the basis of the size and shape of the object being counted. So, if it's that complicated to talk about something as simple as counting here on Earth among beings that are, all biologically the same, how difficult might it be to talk about counting with a creature that evolved in a different cultural environment?
METI involves a wide range of disciplines, such as computer sciences, engineering, linguistics, psychology, and anthropology. But as we try to show the breadth of humanity in the messages, artists like writers, musicians, and painters are also needed. So if we really want to make contact, we will need to make a multidisciplinary effort.
You have to have people involved in communications and engineering in order to think about how do you construct a message from a technical perspective, what kind of equipment is needed, all that sort of thing, what kind of energy is involved in terms of sending a message that could get far enough away that there's a chance it might be intercepted.
Computer scientists have been involved in interstellar communication from the beginning, but now they're engaged in a new way with METI. Because we are using computer languages as the foundation for some of the messages we send to another world. We need to be able to translate our messages into a string of ones and zeros and put them in a format that someone on another world can understand.
Beyond that, you need social scientists involved. You need people like anthropologists like me, linguists, others who work on the topic of culture, language. So we need people who understand how to think about culture and how to think about the influence of culture on creating a message, on understanding a message. There's really a variety of things that go into that.
In any communication process, one of the key factors to take into account is what the interlocutor is like, because depending on its nature, the message could be very different. Taking into consideration that our interlocutor would be an extraterrestrial intelligence of unknown features, the task of creating an interstellar message becomes an even greater challenge.
We don't know what we're communicating with, and I think that is one of the things that makes it extremely difficult. If an extraterrestrial civilization is composed of beings that are fairly similar to us, then one could imagine that they would process information in ways similar to us, and the way that we go about constructing a message should be the way we would construct a message to, another human being.
What do we know about ET? Well, we know nothing, but you can extrapolate. They might be like us. If life starts biologically, it might start not biologically. Life might start in some mechanical way. Well, we don't know. But if it starts like us, then perhaps it will be our type of intelligence. There'll be a brain. It might have a different body, but there'll be some sort of brain, and that will be able to think like us.
There are people like the astronomer Paul Davies who argue that if we find extraterrestrial life, it will be post-biological, some sort of robotic remains of a civilization. Because our present civilization would be evolving itself into a future where we will abandon our biological condition and become post-biological beings. Therefore, if any kind of alien intelligence is able to communicate with us, it would not be biological, but artificial intelligence.
You've had such a long time for life to develop in the universe, millions or billions of years. Intelligence could be out there that's billions of years older than we are. And so the question is, what do they look like? What are they like? There are people like Ray Kurzweil who think in a few generations that we're going to be artificial intelligence. We will develop into artificial intelligence.
Is ET a machine? Is it some sort of hybrid with a machine inside a human brain? Or is it a human plus a computer? Again, we don't know what ET is like at a very deep level, and that's why SETI and METI are so wonderful, because at least we have the hope of finding out.
Our first contact with an alien civilization would undoubtedly be one giant leap for mankind that would come after having decided many key points about the message we will use to communicate with them. One of the first things we have to think about is the kind of language that we would use to compose that pioneering message.
I think there are at least two levels of problems that go into trying to create a message. First of all is we simply don't know what we're dealing with. And the second is we could be dealing with beings that are enough different from us from a biological perspective that it would make just being able to get our message difficult. There's another problem as well. Even if they are like us biologically, culturally, they are different. They have developed a society different from ours. And a lot of our ability to understand each other is grounded in culture. Language is part of that. Obviously, right here on Earth, we have different languages and we don't understand each other very well.
So you have to make certain assumptions. So you have to decide, what we might have in common with them. One idea is mathematics, that mathematics could be universal.
Developing a message destined to be decoded by an extraterrestrial intelligence leads to an unprecedented linguistic challenge. A key point would be to find a basic concept which could be common in the universe, something that any civilization, as different as it would be from us, could understand.
I would imagine that there are certain tendencies that would be likely to evolve in any context where there's intelligence. Self-preservation would seem to be something, which means fear. Would be something I would imagine that most intelligent beings have experience with.
Marvin Minsky, famous father of artificial intelligence, was convinced that communication with an extraterrestrial civilization was possible. In his article, Communication with Alien Intelligence, published in 1985, he argued with conviction, supported by two reasons, as to why aliens will think like us in spite of their different origins. The tenet of economics and sparseness. The argument of economics is based on the fact that intelligent beings develop economic representation systems to communicate. That is to say, as simple as possible. He stated that every intelligence must develop symbol systems for representing objects, causes and goals, and for formulating and remembering the procedures it develops for achieving those goals. Minsky assumed that the concepts thing or object, goal and time would be notions also used by the aliens. On the other hand, the argument of sparseness states that every evolving intelligence will eventually encounter certain very special ideas. For example, about arithmetic, casual reasoning, and economics. One human language that could embrace both tenets Minsky suggested is mathematics, as it is a very economic and conceptual code of symbols to communicate with, as well as being able to represent much simpler ideas than other languages.
As we think of communicating with another civilization through mathematics, we need some starting point. And so we start with the most basic, and that is counting. Simply 1, 2, 3. So sending a pulse, 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 pulse. And then, once we can communicate counting, then we start with basic arithmetic. 2 plus 2 equals 4, 3 plus 3 equals 6. And step by step, build up from simple mathematical principles to complex mathematical principles. The principle then is not just to find a universal calculus that everyone knows, but to find some way of going from what seems the most basic to the more complex. So it's not even finding what the extraterrestrials and we have in common, but teaching them our way of doing mathematics.
So there are a number of different possibilities. Probably the safest thing to do is to try a variety of them and not just rely on one. Try a variety of different message compositions and see what might work.
We can use counting to talk about mathematics. We can use counting to talk about the physical structure of the universe, the chemical elements that make up the universe we see around us. Another way that we can use counting is to talk about our sense of aesthetics. What is it that we see as beautiful? The Italian mathematician Fibonacci had a different way of counting than just 1, 2, 3. He said, take two numbers, add them together, and then move on and repeat that over and over again. So 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, and it goes on and on and on into infinity.
Fibonacci discovered that by analyzing the proportions between those numbers, we can see many natural structures described in that basic series.
And it makes sense because these are describing objects that grow. There's a natural link between these geometrical shapes and the way objects are formed and change here on our world. But those same proportions are tied into at least part of our sense of what's beautiful. So it's going to be a tremendous challenge to communicate something about what is quintessentially human to an extraterrestrial. But with something like the Fibonacci series, we can at least begin.
One way to do this, and this is in Carl Sagan's novel Contact, which was made into a movie starring Jodie Foster. One way to do that is to send a message that consists of a string of numbers that's the product of two prime numbers. So you can factor it into prime number not divisible by another number. 3 and 5 are two prime numbers. So if you send a string of 15 digits that you factor that into two primes, you can make a picture. So it could be 3 across by 5 down, and then you can actually make drawings. So this has been thought of a long time ago. If you take bigger products of prime numbers, you can make a big raster image like that and transmit it, which is something that probably an alien civilization could figure out.
Even though there have been many authors who have pondered the issue of communication with an alien civilization, only one, Dr. Hans Freudenthal, a Dutch mathematician and professor at Utrecht University, was able to develop a specific language for interstellar communication, Lincos. The word Lincos is an abbreviation of the Latin expression lingua cosmica, and it was used to name the artificial language created in 1960 by this mathematician who described it in his book, Lincos, Design of a Language for Cosmic Intercourse. Dr. Freudenthal's book is divided into 4 chapters. The first chapter is called Mathematics, and it focuses on learning natural numbers expressed through a series of repeated pulses separated by pauses, and through different mathematical signs such as plus, minus, equals, less than, or greater than signs. The second chapter, called Time, introduces means for measuring durations, referring to moments in time, and talking about past and future events. The third one, Behavior, introduces actors speaking to each other, asking questions, disapproving, quoting other people, knowing and wanting things, promising, and playing. The last one, Space, Motion, Mass, reaches as far as describing physical features of human beings and of the solar system. Lincos is, without doubt, a brilliant tool to attempt communication with an extraterrestrial intelligence. And as of today, the one and only artificial language in the world created with this aim. The creation of a universal language could be essential to communicate on first contact. But there would still be another controversial matter left to solve: the content of the message. What would the first contact be like? What could human beings say to another intelligent species? What introductory message could we compose about human beings?
Some people think the message matters a lot, but on my viewpoint, the ET is almost certainly 1 billion years more advanced than us. It will know everything about what is to be done, so anything you send, they can understand it. We will have difficulty in understanding a message from them, but if they're clever, which they certainly are, they'll make the message in terms which we can understand. It's like talking to an ant. Now, I can talk to an ant. By talking, I mean modifying its behavior. If I put a sugar lump down, the ant will move to the sugar lump. And in terms of the ants, it's been communicated with. Of course, the ant doesn't realize that I'm intelligent. So if we get a message from them, it will be something we can understand, but there'll probably be behind it. There will be things which we just can't, which our brains just can't cope with.
Some people say that you should send all the information on the internet, but I think there are ethical questions. Are we putting the Earth in danger? Are we putting the people of Earth in danger? The opinion of the people in METI International is we should have a very simple message composition to start with, and then see if we get a reply, although the replies will depend on the distance. If it's the nearest star, Proxima Centauri, it'll take 4 years to get there at the speed of light and 4 years to get back, so it'd be 8 years to get a reply.
Prior to sending the messages, there are many important decisions to make, such as the strength of the signals, the targets, the message composition, or what to say about ourselves.
I think, we should show our best face, but it would be naive to cover up all our bad things. So you'd want to send as much as you can, and in different ways, because talking and writing and physics is one way to communicate, but there are many other ways. Music communicates in ways which we can't really write down. You can't explain as Beethoven's symphony. So we should send music, we should send pictures of people dancing, because dance is a good way of communication. So I think we should send a wide range.
In the last 50 years, there have been sent several messages of different nature. Some of them have been messages in the form of a plaque or a record attached to a spacecraft sent into the deep interstellar space, while some others have been radio messages sent from radio telescopes.
One of the earliest attempts to send a message to another world was conducted by NASA in 1972, when it launched 2 Pioneer spacecraft that had as their primary mission an exploration of our solar system. There is a very simple greeting etched on a metal plaque attached to the side of the spacecraft. And it is a message that is written in pictures and in the language of science. So there's a description in a basic binary numbering system of how we count. And so the Pioneer plaque starts with some simple physical and mathematical concepts, but then uses that to describe something about our universe. A few years after the Pioneer spacecraft was launched, NASA sent a more ambitious message into space. It was born on 2 Voyager spacecraft that journeyed throughout our solar system, and on each of those spacecraft there was a golden record that includes pictures of life on Earth, human beings, natural structures, a description of our solar system, and an attempt to communicate something through mathematics and science. You also get greetings in 55 languages and a sampling of music from around the world.
Hola y saludos a todos.
Oiknis poteste chairete, Erenikos prosphilus
The content of those golden records on board the Voyager spacecrafts were an attempt to capture the richness and complexity of humanity. They included samples of different natural sounds from the Earth, as well as a wide selection of music from all over the world, from traditional and classical pieces to rock and roll and pop songs.
The photos, I think, are very problematic. They send an extremely warped image of our planet. They're all happy and nice. They don't show poverty. They don't show atomic bombs going off. They don't show the devastation in Europe after World War II or anything like that. It paints this rather misleading picture of life on Earth, and I've often thought that if ET actually ever intercepted one of the Voyager spacecraft and looked at it and then said, wow, let's go check this out, they'd be really, really disappointed because Earth isn't anything like what it was presented to be like, and they might even be irritated because we seem like a bunch of liars, you know, intentionally misrepresenting our own planet. I think one of the real problems with those types of messages is that we have to represent what we actually are, and the Voyager messages don't do that.
The most famous message that was ever transmitted to another civilization was sent from the Arecibo Observatory in 1974. And it's a beautiful message. The basic principles of communicating mathematics and science in a brief message are still the fundamental ideas that drive message composition today. But the target for that Arecibo message is not exactly what we'd want, because it is transmitted to a globular cluster called M13 that is 25,000 light years away. And so that means if we get a reply, it won't be for another 50,000 years.
After Arecibo's message, similar messages have been sent through multiple radio telescopes throughout the world. Among the most recent, the Cosmic Call messages stands out. The first of them was sent in 1999 towards several close stars from the radio telescope RT-70, located on the Crimean Peninsula. This message, based on Lincos and created by Canadian astrophysicists Yvonne Dutil and Stéphane Dumas, was made up of several sections, like the Rosetta Stone, a copy of Arecibo's message, a bilingual image glossary, the Brostad message, as well as diverse texts, images, videos, and music.
They sent pictures. First of all, very simple pictures of molecules which should be common in the universe, so ET could understand that, and then pictures of the Earth, and then pictures of people, but in very cartoon-like form, to be cheap, you know, very, very simple pictures, not detailed. But they were just sort of basic background knowledge. There wasn't much in the way of history or philosophy or anything like that.
The experiment was repeated again in 2003. On that occasion, Even though the message was almost the same, it headed toward different stars.
Our modern-day approach to METI is very similar to the Arecibo message, but it differs in two fundamental ways. So the first difference between our plans and the Arecibo message is to focus on stars that are much closer to reduce the round-trip time. The second difference between the Arecibo message and the messages we're planning is we're not going to send them just once. Instead, we will repeatedly, over and over the course of months and years, send the same star the same message. Because that's what we would require to detect intelligence on our world. When we get a signal that appears just once, it's exciting, but it has no credibility. So by targeting nearby stars and doing it over and over, we're proposing a radically different way of doing METI.
We hope that, sooner or later, some of those messages may be decoded by an alien civilization that would send us back a message with their response. If that eventually happens, it will demonstrate the success of the whole METI project. Communication with an extraterrestrial intelligence, much more advanced than us, could give us the keys to help the survival of our species. Perhaps we would start seeing our planet as a place without borders, as a whole. However, the absolute ignorance about the possible aims of an extraterrestrial intelligence is what has led some scientists to voice their misgivings about announcing our existence to extraterrestrials, at least until we know their intentions toward us.
METI has possibilities of being a great new technique for making contact, but it's incredibly controversial. In 2010, Stephen Hawking said, if we get a signal from another civilization, do not reply. They may come to our Earth and strip mine our planet, take our scarce resources. Well, it made a little sense to say that in 2010 because we didn't know that Earth-like planets are everywhere. But now we know that rocky planets are abundant throughout the universe, so it simply doesn't make good economic sense.
If a more advanced civilization came to Earth with evil intentions, we couldn't do anything to avoid it. If that was the case, now it would be too late. Any civilization with the ability to develop interstellar travel may already know of our existence. As for 2.5 billion years, our atmosphere has been giving off biosignatures, providing evidence of life on Earth. And even more, for nearly a century, our radio technologies have been emitting signals into space that could be easily detected by them.
There are definitely detractors about METI who think that it would be very dangerous. It almost comes down to whether you're optimistic or pessimistic about what's out there. My view is that we can't cower here on Earth and hide from the universe. We're part of the universe in the same way that we don't want to be isolationist.
I'm not 100% sure whether we should actually go ahead and send a message. I personally am kind of back and forth on that. I recognize the potential risks that are involved. As I said, I'm not convinced those risks are all that significant, but there's an awful lot of unknown out there. And so we do need to think a lot about those risks.
You might argue that these civilizations out there are so much older than us. You know, they've had a long time to develop. They could be thousands or millions of years older than us. And you would hope with longevity that they would have developed better morality and would have found a way to do away with war, but there's no guarantee of that, so we just don't know.
I think that most of the arguments against METI are really related to risk and the question of who has the right to assume risk for the entire population of our planet, and really the planet as a whole. And how would we even arrive at a decision as to who would have that responsibility and that right?
There might be risks when we expose ourselves to the universe by sending messages, in case there were a hostile alien civilization out there. There are voices that accept there can be no advance without taking on certain risks. Although there are others who think it's too risky. There is no consensus about this controversial issue. If someday we could finally communicate with an alien civilization, we would finally know that we are not alone in the universe. This transcendental revelation would without a doubt change our self-understanding as a species and as a civilization forever.
I think it would change our cosmological worldview from the point of view that it's a very different universe if we are the only ones here versus if the universe is full of life. So it would be a case of the almost purely physical universe in which we are a fluke versus the biological universe which is full of life. So it would change our cosmological worldview. It would also change, I think, our theological worldviews, because people will have to take into account how their theologies are impacted if there's other life out there. A lot of people think that religions would certainly survive, but because they have survived over thousands of years and they seem to be necessary for humans, but that they would have to be changed quite a bit. So theological world would be changed, cosmological worldview, theological worldview, but also just our everyday worldview as we become more and more sort of have a cosmic consciousness, which we're already getting from the space program, from NASA, seeing the full Earth from various spacecraft, and seeing the pale blue dot from the Voyager spacecraft, seeing Earthrise from the moon, seeing those Hubble Space Telescope images.
I think we could learn a lot, and from my own standpoint, that our single biggest problem here on Earth, bigger than terrorism and war and everything else, is just sustainability. How do you keep a planet going for long time periods when you have lots of people there or lots and finite resources? An intelligent civilization out there, it's almost certainly much older than us, and they must have conquered that problem of sustainability a long time ago. So what I would be looking for is to figure out how do we make it through these crises that we see coming up within the next 50 to 200 years.
I think for intellectual elites, and scientists are among intellectual elites, it may have a rather profound impact on the way that we think about our place in the universe. And in the long run, that may affect the way humans think about themselves as a whole. I think it will be an extremely important moment when it's looked back at maybe 500 years from whenever it happens.
That first contact could kick off a new era for us, an era where we start to live our lives aware of the fact that we are not alone here. An era in which we could begin to learn more about ourselves, about our own existence, and about our own future from another intelligent and possibly much more advanced civilization.
I think in the process of doing SETI and doing METI, it helps us to think more about who and what we are as beings. And so I think there's a great deal of value in working through the process of imagining how we would communicate with non-human intelligence. There's much we can learn about ourselves in doing that, and about the kind of assumptions that we make about what intelligence is.
You can think of SETI and METI as peering into our future. If we can discover what an advanced intelligent civilization is like, we'll find out what we're going to be. And it would be very nice if there are such things, because one of the worries is we're going to destroy ourselves. But if there are advanced civilizations, we may have a chance to become like them.
It's hard to imagine that this desired contact will not happen sooner or later. For now, all we can do is keep sending messages and tracking the signals that return, seeking proof of the existence, perhaps around a very, very far away star, of a civilization that we can communicate with.